Hi, my name is Rachel Ransom. I'm currently studying a graduate diploma of information technology through QUT, and I'm just about to finish my first subject, which is IFQ 551, Computer System Fundamentals. So today I'm going to provide you an overview of the micro project that I completed for that subject, and the following slides will provide you with an overview and also information about the various challenges that were undertaken. So what are we going to cover today in this presentation? Well, I'll give you an introduction to the project design. So what did I actually decide to build as part of the project? I'll provide you with a practical demonstration of how the actual project is working. I'll talk about some of the challenges and limitations that I encountered as part of the project, and I'll also talk about the future direction and possible design improvements for this project. So let's get started. So the main objective of this particular micro project was to design and build a basic computer system using the Raspberry Pi, which is a microcomputer essentially, utilizing modern computer technologies. Some of those technologies that were utilized as part of this project that I'll go into in more detail included web technologies. The main aim of the micro project was to really gain knowledge of how a computer system operates, having absolutely no exposure to computers and how they work previously. And one of the fundamental goals was to gain knowledge of the fundamental computer technologies that exist and work together to create a working computer system. So what we had to do is we had to build a project from scratch using the Raspberry Pi microcomputer. And what I decided to do after a lot of research and a lot of thought as to what and how I could build something, I decided to build it and configure the Raspberry Pi microcomputer to track the location of the International Space Station passing over Brisbane, Australia, which is where I live. I'm really interested in space and the frontier of space, so I was really keen to incorporate that as part of my project. So what did the project actually include? Well, obviously, as with any modern computer system, the project's design incorporated both hardware and software components along with the necessary technologies required to effectively retrieve data from the International Space Station tracking website. The hardware of the computer system refers to the physical, tangible equipment and devices which provide support to major functions required for input, processing of data, and output of data and communications. And essentially, without both hardware and software, you don't have a computer. You can't have one without the other. They are intertwined and interconnected. So it's really important that you incorporate those items within any computer design. So what did my computer design look like? Well, it took a while to get to this stage, but I'll go through it in a bit more detail. So starting out with the Raspberry Pi, which is essentially the microcomputer that we used, I decided to use my laptop computer that I used for work to provide the functions of both the keyboard and the monitor. So the keyboard and the monitor essentially provided the input and output functions for the computer system. So how did I connect the laptop and the Raspberry Pi together? Well, I used a USB to serial port connector, which is essentially a piece of hardware, again, computer hardware or computer technology that allowed me to connect the two devices. So once I had them connected, what I wanted to do was actually make sure that we had a secure serial connection between the two systems. So using PuTTY, which I installed on the Raspberry Pi, I actually connected to the computer or the laptop computer and the Raspberry Pi. So essentially I could see and type commands into the laptop computer and have those actually present within the Raspberry Pi terminal emulator. So once I had the terminal emulator connection set up and ready, I started to build my Python scripts. And Python, I decided to use Python as a programming language because it is very easy to use. There's lots of different libraries that exist to help would-be programmers like myself to actually understand and incorporate within any script that I created. I have had absolutely no experience with programming before, and this was probably the most challenging step in my design. I really struggled with some of the concepts around the terminology and syntax that you use within Python. I think I would have struggled with any particular programming language, to be honest, but I chose Python primarily because I read and heard that it was one of the simplest programming languages to get your head around. So once I had my Python scripts built, which essentially were two scripts, a main or master script, and then another smaller script, which was actually called as part of that master script, I started to build up and test the design. So essentially the Python script, the first step in the process would send a GET request or a HTTP GET request to the International Space Station web server to retrieve XML data, location data in relation to Brisbane, Australia for the International Space Station. Once that information was found and received and retrieved from the web server, HTTP response was sent back to the Raspberry Pi, and that was then incorporated and used by the Python script to then push that information through a post status message to the Twitter web application. Now, in order to ensure that there was a secure connection between the Raspberry Pi, the API, and Twitter, an OAuth authorization request and response protocol was used, which is essentially a secure protocol that connects or can connect two systems together. So now that you have a basic understanding of the project design, what we'll now do is jump in and I'll provide you with a very quick overview of the project and a demonstration of the project and how it works. So I'm just going to exit my screen. Now, one of the first steps is I will show you, in order to get this to work, I actually had to set up a Twitter account. So you'll see here my Twitter application or my account. There's really nothing in here. I've never posted in here, and I'm logged in as myself. So this will be the final step to check whether the design has actually worked, is whether the Twitter message will display in the Twitter account that I've created. So let's jump into it. Well, the first thing that we had to do was open up the PuTTY terminal emulator. So the PuTTY terminal emulator is essentially the command terminal where you can basically send instructions to the Raspberry Pi. In order to actually connect the PuTTY terminal emulator or the PuTTY software to the Raspberry Pi, we have to then firstly specify the COM port that it will connect through. So for my particular computer and Raspberry Pi, it's COM port 3. You then have to specify the speed of the connection. So the default setting for a Raspberry Pi in terms of connection speed is 115/200. So you specify both the serial COM port and the speed of the connection. Once you have those defined, then you just click open. And there we have our serial terminal emulator screen. So the next step is to log into the Raspberry Pi. So once logged into the Raspberry Pi, the first thing that I usually do is I just see what directories and files exist on the Raspberry Pi. So you can see there is a Twitterbot directory there that I've created. So we need to navigate to the Twitterbot directory, which is where essentially the Python files have been stored for this particular project. So we'll just navigate to the Twitterbot directory. And let's have a look and see what's actually stored in that directory. So you'll see at the moment there's 3 files that exist within that directory. The command that I used for that was ls, and that gives you a listing of all the different files that exist within that directory. Now, the 2 main Python files that I used for this particular project was the lss_tracker_gen.py and the twitter.py. The twitter.py is essentially the main Python script that subsequently calls lss_tracker_gen.py. So what we want to do now is we want to execute that particular Python script and see what happens. So to execute the Python script, you just type in Python twitter.py. And you'll see that this particular message displays on the screen. Okay, so it's saying that the International Space Station is passing overhead on Friday, August 21 at 6:02 p.m. for 3 minutes. Okay, so that's tomorrow, which is pretty cool. I'm looking forward to that. So that essentially means that those 2 Python scripts work together to retrieve XML data from the International Space Station website and then post that information to the screen. So what we want to also see is whether it actually posted that information using the Twitter API as an intermediary web service to Twitter itself, to my Twitter account, because I want everyone to know that the International Space Station is passing overhead on Friday, August 21 at 6:02 p.m. So let's take a look at our Twitter account and see what we can see. And you'll see there, it looks like I've posted it, but it's actually coming from my Twitter Python script. The International Space Station is passing overhead on Friday, August 21, 2020 at 6:02 p.m. for 3 minutes. So that essentially is showing that the script is working and it's working well. Now, so what were some of the challenges and limitations that I encountered? Well, I encountered quite a few, actually, to be honest. I encountered challenges with the setup and configuration of the Raspberry Pi when I was first flashing the SD card with the operating system. It didn't work, and I had to do that quite a few times. I had to basically wipe the SD card and start again quite a few times in order for it to actually work in the end. Installation and configuration of the Twitter API. When I first set up the Twitter API and tried to post a message through that API to Twitter, I received a permission denied error, and that was actually caused by the fact that the configuration settings in the Twitter API were read-only. So I had to read up about that and actually understand what that meant and how to actually resolve that. But to be honest, the majority of the challenges centered around knowledge and understanding of the Python code. I encountered numerous errors that were presented during construction and testing of the developed Python script. Some of those errors were syntax errors, so knowing when to use quotation marks and when to not, and following Python coding rules. I used a lot of forums or programming forums for Python to actually try and understand what I was doing wrong, and it was quite a laborious process. I was unable to write Python script that would regularly check and post a tweet with new information as it occurred. But, you know, that's something that I'm looking to do in the future. I think it's really cool that I can pull down information from the tracking website and post it to Twitter so the entire world can know that it's the ISS is passing over Brisbane at a particular point in time. So what are some of the future directions and improvements? Well, in terms of, I thought of quite a few actually in relation to this project. So, and I've broken them down into 3 different areas. Hardware technologies, so to further expand the project and its capability, I thought about connecting a small tablet or an LCD device or smartwatch to the Raspberry Pi in order to track the exact location of the International Space Station in real time. The LCD connection could be established using a Raspberry Pi official LCD display and a DSI ribbon cable connected to the Raspberry Pi DSI port. That's some of the things that I found as possible expansions to this particular project. I also thought about, well, what can you do with that information? So I was thinking about retrieving open source scientific data, which is available on the ISS website, and storing that in a cloud-based SQL database. And I would do that through using a platform as a service. So I would build the SQL database within that platform as a service environment, and then retrieve the data and store it in that particular location. I could then interrogate that data at any time and do research on it using, obviously, Python scripts to get the information that I need. I also thought about GET requests written in Python to receive XML data from the International Space Station and displaying the data on a purpose-built website written in HTML, which is the hypertext markup language or the standard internet language that's out there at the moment for building websites. So all good stuff and things that I would really like to continue to explore in relation to this particular project. In relation to software technologies, I thought about modifying the Python code further to allow for greater flexibility in the data retrieved and tweeted to Twitter. I've also thought about automating and scheduling the execution of the developed Python script using cron. So cron is a time-based scheduler used with Unix-like operating systems to schedule programs and tasks to run at the point of booting a Raspberry Pi. Automating the developed script could be used to check the ISS website at the same time each day and post a message to Twitter with updated location information, so I wouldn't actually have to touch the program. It would essentially run on booting the Raspberry Pi, which would be pretty cool. So thank you very much for taking the time to listen to my presentation. I hope you enjoyed it. I found this project extremely challenging, as I said, but I really did enjoy it, and I have learned so much about computer systems and how they operate. I'm really looking forward to further expanding my knowledge in the field of information technology over the next couple of years as I continue on with my course. So thank you.